Continuing with the day 2 session of Git, right? So yesterday we covered the basic part of the Git, right? Like starting from what is a Git actually, what is a version control system, and what are the different generation which we have come across with the version controls, right? First generation, second generation, and third generation. As well, we try to understand about like how Git comes under the distributed version control system, right? So what is an advantage of being a uh, be a, or what is an advantage of Git being in the distribution version control system? Also, we covered up, right? And also we have covered something on how to work on Git, right? Which means that you have to first install the Git package. Though we have not did it any practically, but theoretically I just explained, right? We have to install the packages, right? It is based on the Linux flavor, or it is the Windows, or it is on a Mac OS. So wherever you go, you can install Git, and Git is easily installable because it is a platform independent. It is it can be installed on any operating system. Correct. So in today's topic, right, what we'll be covering up. So in today's day two sessions, we will try to understand the Git overflow, overview or overflow, as well as we can even check like we will also try to understand, or we'll try to get to know, understand about some of the Git commands. Actually, very very basic today. We are going to understand about the Git commands, as well as we can see that how to install the Git server, how to install Git, how to install Git in on premises. So you can say how to install a Git server. You can say Git server in on premises machine or server. Suppose you want to locally you want to install it. Actually, locally you want to install the Git, and you want to make that as a Git server. So how to do that? So these are the few topics which we would be covering for today. Okay, fine. So now, what is a Git overflow? See, to understand about the Git or the Git commands or the Git servers, right? We need to understand certain stuffs about a few of the terminologies what we use in a Git actually, right? So what are those terminologies? So you have to understand about what is a Git server first. Git server, Git client, okay, CLIENT client, and you can say that repositories. Again, within the repository, you have two types. One is a local repository, and other is a centralized repository. So these are some of the terminologies which we have to understand. Okay. After that, what else you have? You have something known as a push, pull, as well as something as a branch. So today we'll be understanding about this. This is not what it's a Git overflow. To understand the Git overflow, you need to understand certain terminologies. Okay. Now, what is a Git server? Now Git server is something like, suppose you go to the market, or you go to any like any company where they provide the servers, right? So you go and you buy the servers. Actually, you go and you buy the big server. You go and buy the big server actually. So this is a big server actually, like this. And here what we will do, right, in this big server we will try to install some software actually. So first you will bring the you will try to buy the server, a big server, and then you will install some operating system in that. Right, let it be Windows or Linux, right? Preferably Linux. We say that okay, Windows or Linux, you install it, and after you install Windows or Linux, then what you'll do, you'll try to install some software. So what is that software? That is a Git software. So you'll try to install the Git software, Git package or Git software. Now, once you install a Git software, what happens? This machine or this server will be considered as a Git server. It will be considered as a Git server. No doubt, it still act as a node, but you can make sure that you can make it as a Git server. Okay. Now, after this, you have many of the users who want to push their code, or who want to commit their code into this Git server. So there are many of the users actually, like this. There are many of the users are there like this. Many of the users means you can say many of the developers. Suppose consider these are the developers. These are the developers. These are the developers. Okay, even the developers also are given the machines, right? They are also given the machines, right? They'll also be given a laptop to them, and even they'll install what? They'll install the Git package or the Git software they'll install in their laptop. Correct. So consider these are the machines, or these are nothing but the users or the developers, or these are nothing but the clients. Also, you can say Git clients actually, right? So they will try to have what they'll do. They will try to install, and this all these machines or the users in their environment they can have any operating system. So this user one, the first user, he can have Windows operating system which is running in his laptop. This laptop or this user will have a Linux, that is CentOS Linux. This server or this machine or this user will have a Mac OS. So you can see that there are different flavors of operating system which are there in a different users. Linux, Ubuntu, like that. It could be anything like Linux, Red Hat, RHEL, Red Hat. Right. Now, here also what happened, right? In each and every user machines or in their own user environment, they would be installing the Git. Git would be installed over there. Git, they'll install the Git software or the Git package, they'll install it. And what they'll do, right? They will try to write some code and they'll try to push that code into this server. So they'll try to push the code into this server like this. So this is something like a local machine where they're writing some code, and once they write the code, what they will do, they will try to push this code into this server. Means this server will act like a centralized server or centralized Git server. So centralized Git server is a place where all the codes are pushed or all the codes are placed or all the software source codes are committed here. So that's it, and the place where it is a centralized server and where it stores all the software code or the software source code are placed. This we call it as a Git server. Okay, and whoever is pushing the code from here, this will act like a Git client. But once they do a lot of changes into the software code, finally they want to save that code. They cannot save it in the local machine, even though there will be a copy of that whatever they have did the code they have written or whatever the code which they have written, right? That code will be there in the local machine, correct? But ultimately, at the end, they want to push into some centralized server where all those software codes are maintained or the source software code versions are maintained or history is maintained. So that only it happens with the help of a Git server. So basically, you need to have one centralized server where we install some software, that is a Git package, as well as few more software you install so that it will act like a Git server, and all the other machines who are there, who write the code, they'll finally at the end of the day or whenever they finish writing the code, they'll push that code into the Git server. So this is a Git client and the Git server. Correct, guys? Now, what is a repository? See, a repository is nothing but it's a folder, sir. To be in a very simple language, what is a repository? Repository, repository is nothing but it is a kind of a folder, sir. It's a simple folder. Right? In Windows or Linux, you can create a folder or you can create a file. Sorry, you can create a folder or you can create a directory. In Windows, we call it as a directory, whereas in Unix or Linux, we call it as a we call it as a directory when it comes to Linux or Unix. We call it as a folder when it comes to Windows. Correct? So what I say, what is a repository? A repository is nothing but it is a simple folder. We can call a folder as a repository. But that suppose in Linux, if I create a directory, mkdir, I'll create a directory by name something. If I take a name something like I will create a directory by name Rajesh. So after I create a Rajesh, I'll go to the Rajesh. I'll go inside a Rajesh directory, and then I will try to create some file. Touch Alice, Bob, John. Some few files I'll create. I will also create few more directories like file one, file two, like that. I will create some directories with this name. Now, all these files are getting created and directories are getting created under the Rajesh directory. But assume that after some time, somebody comes and they will remove these files. So do you know that which are all the directories or which are the files who are got deleted? Or does it maintain any kind of a versioning or history? Does this folder will maintain, the Rajesh folder will maintain the information about like which are all the folders, files which were sub files or sub directories got deleted at some point of time. So it doesn't drive because a folder by default it doesn't maintain any kind of a history or the versioning. So we call this as a plain or a simple folder or simple directory. But whereas in case of a Git, actually, we cannot say it as simply as a folder. We want it is obviously it's a folder, but we need to make sure such a way that this folder will become a repository. How to do that in case of when it comes to the Git, actually, you have to create a folder like mkday Rajesh. You have to create a folder. You have to go inside the cd Rajesh, and after you go inside cd Rajesh, you have to just if you want to make it as a versioning, you have to just simply run on command git init. So this is the command you need to execute so that Rajesh directory or the Rajesh folder will act as a repository. Clear, guys? So once you create a folder, create a directory, and you run a git init command inside being inside the this directory, now this directory is not a simple directory or simple folder. Now it acts as a repository because now the versioning gets started up. It means that it maintains all kind of a versioning or revisioning about what are the changes happen within inside a directory. Suppose the same thing inside directory after you do a git init, what you're doing, you're trying to create some file, you're removing a file, you're creating a directory, remove directory, many operations which you're doing inside a directory. Now what happened, right? The Git will maintain all kind of those changes, whatever you did it. So that how it does, because like you are initialize it with the Git, with the help of a Git init. So once you initialize with the Git command, this folder is no longer called as a normal folder. This will be called as a repository. So now what is happening that here in case of a Git server, what you will do, right? You will create some folder, something like this. Okay, let me rub this so that I need some space. So what you will do here when it comes to the here you create some directory. Suppose I want to create a repository. What you'll do, you'll say mkdir slash some project, something like bank repository. Okay. So you create a directory by name bank repository, something like this. After this, what will happen that you will do a CD into the bank repository. It means it is like a repository you have created. And here what you will do, you will run a command git init -fn bear like this. You'll run this command. Once you run this command, this bank repository, which was earlier called as a folder, simple folder, now it becomes a repository. So this bank repository will be called now, it will act like a centralized repository, because ultimately all these people who are writing the code, they're committing the code under this bank repository. Clear, sir? So this will act as a repository. So there are two types of repositories. One is a centralized repository and other is a local repository. Now what happened, right? What is a local repository? Local repositories are those repositories which are maintained locally by each and every client. These are Git clients, right? These are all Git clients or Git users, we can say. Git client or Git users, right? Git clients or Git users, correct, guys? Now, what is happening that here, suppose that some person like user one, he is having his laptop. In his laptop, he is having a Windows operating system. Under the Windows operating system, he has installed the Git software. Okay. After that, what he's going to do, what he's going to do inside his machine, he'll go to some particular folder or into some particular drive. There he will run this command mkdir slash something like day1 directory. Okay. Get inside a day1 directory, and he will simply he want to start writing the code, changes everything. He want to work under the Git. What he will do, he will try to just execute a command git init. He's initializing the Git. As soon as you run this git init command, what happens that this slash day1 directory will become a It is a folder actually, which he created earlier. But now this folder is not be called as a simple folder. Now it becomes a repository, right? Because you have run the git init command. So as soon as you run the git init command, it means that the versioning or the revision will get started under the /dev1 directory. So whoever are changing any kind of a stuff within the /dev directory, suppose somebody is creating a file, some people are creating a directory, somebody are changing a file, everything, whatever the changes which you are doing, right, that would be it maintains a revision for that revision, or it maintains each and every change revision for that. So now you can say that repository is not, but in short, repository is a totality. We can say a repository, how we can write it down is not, but a repository so what is a repository means? In short, we say a repository is a totality of the history of software project. Okay, that's what we call it as a repository. Repository even called as a folder also, but it is no longer a simple folder. It becomes a repository because as soon as you run a git command, git init, it becomes a repository. Correct. So now here what is happening that suppose this user one. So this user is nothing but his name is he's a user one actually. Now what he does, right? He is having a project actually. He will be doing some for the whole complete 1 day of work, right? He will be doing some 20 changes into a file. Do you think that the all suppose he does one line of code, again he will push that change to the server? Okay. So as soon as you push into the server, again what happened? The Git server will maintain one version for the whatever the changes have been pushed by this user one. Again what happened? The user two will try to do the second line of change. Again he will push, and again one more version will be maintained for the second change what he has been pushed. Like that, suppose assume that this user has having some 20 changes which he has did the file. Do you think that for each and every small change he will be keep committing the code into the Git server, and the Git server has to maintain the each and every change? It has to maintain a version, right? So it is very difficult, right? Because you are making very complicated. That's the reason what happened, right? What they did, right? Boss, you don't do that way. What you do that actually, that in your system itself you install the git fine, you create a git, you create a directory where you want to write the codes and all. So that's the reason he wrote mkdir/dev1. Okay. After that, what he did, did a git init command. He executed this command so that the /dev directory one will become as a repository. Now, inside this repository, what he will do, no, he will try to write the changes. He will be doing the same changes over there, as well as he is committing the same changes in his local itself. So what he does, he will at the whole complete day, right? He might do some 20 or 30 changes into the source code file, but he's committing everything in his under his local repository, under his local system only. But after at the end of the day, once he completely does all the changes, then what happened that he will try to commit the code changes at the end of the day. He will push his code to this centralized repository, right? So that what happened, right? Whatever the versioning which you have achieved over here, that will only happen in your local itself. Because if you keep doing one small change and keep pushing to a central repository, right, or into the Git server, this has to maintain a lot of versioning. So this is the only user who's working on the project. Think about that there are multiple users or they're working on the same project. Even if they started doing these changes, how many revisions it has to maintain? So that's the reason they will say that you don't do all those things. You don't just to push the code by doing only one change. You do maximum changes in your code. By end of the day, before you leave, you can commit that code into the repository like that, so that this will maintain a less revision, right? And it will avoid all kind of a complications. So that's the reason we have a local repository and we have a centralized repository. So local repository, you know that each and every client or each and every user or the developer, they will maintain their local repository within their laptops or within their system, right? So all these users will maintain their local repository within them. And at the end of the day, or whenever they want to feel that they want to commit, at that point of time, they will they will commit the entire changes. Like this here, as I said, like user one is developing some kind of a code. He has did some 20 changes. All those 20 changes together at the end of the day, he's going to push into the centralized repository or under this bank repository. no bank under this bank repository, he will just push that code. Clear, guys? So that is what it is. So this is all about the repositories. Okay. Now, what is a push actually? Push is something like it is a Git operation. It's a Git command, we say. So whatever the changes which is done by the particular user, he want to push that code into a centralized repository. He will just run a command, Git push command, like this. So later we will see what is that command. He will do a push operation. He will do a push operation like that. So that once you do a Git push operation, so whatever the code which is then in your local repository, that would be moved, or that would be moved into a central repository or into your main Git server. Okay, and you know that these are all the users, like user one, sorry, user two, user three, user four, user five, user six, user seven. Assume that he is a user six actually. He's a user six, correct? He's user six. He has gone for the vacation for 1 week, and within that 1 week many of the people have did the software code changes into the project, and they have did the push operation onto the central repository. Now after his vacation, this user 6 will come back, and he want to see what are all the changes which are done by various different users or various different developers. He need not to worry, because he's already having some local repo within him. What he will do, whatever all the latest change which is there in the bank repository, right? In the bank repository, he has to just pull that actually. So that's the reason what he will do. He will do a pull operation. So from here, he will try to do the pull. This user six, you need not to go and ask each and every user, hey, what you did the changes and all. It's not required. He will just try to do a pull operation. So what he will do, he will run some git command like git pull origin master, something like that. He will execute. Right now, you don't worry about the commands. You are just want to learn about the high level concept that he will going to do a, he going to take a pull operation. When he does a pull operation, what happened? Whatever the latest and the latest changes which are there in that all the source code will be pulled to under his directory. So suppose that this user has created a directory, something like mkdir slash dev6, something like this, and he will be inside this slash cd slash dev6. So being inside this folder, what he will do, no, he will try to run one command. He want to pull all the codes, whatever are there, right? He will just say git pull origin master. Like this, he will do a, he will execute that command. So once this user six execute the command, whatever all the codes are there, that will get pulled into this directory slash dev6 directory. Clear, guys? So push pull is there. So these are the two major operations which we'll always be using. You will be when you are working on a Git. Many times you'll be doing a Git push, Git pull, Git push, Git pull. It is, you will be every day you'll be doing a lot of times actually. So we have to understand what is this push and pull. Okay, we will go through it later also, some more things about these commands. But right now in a very high level, I'm just telling you. So because this is one thing. Uh, there are a lot of other commands are there which we'll be discussing, but today I'm just telling you in a very high level. Okay. Now, what is this branch actually? What is this branch? Branch is something like, okay, let me do one thing. Let me rub something so that I can explain what is a branch. Okay. Now, what is a branch? See, suppose assume that your company project manager comes, and he will say that actually, guys, you need to develop some software, something like a VLC player software. You need to develop. You need to develop it. Okay. So he will give that assignment to this engineers. All these 7 users he will give you. So you need to develop this VLC software or your VLC player. You need to develop it. So again, what he will say that actually, okay, you do one thing. This 3 users, user one, user two, user three, you guys have to develop the VLC player, and the version should be VLC 1.1. This is the version you have to develop. He says. Similarly, what he will do, he will tell to the remaining other 4 engineers that you also start working on the VLC player, but you need to develop the VLC 2.1 version. VLC version 2.1. Okay? So that is what he will just divide this work between these 7 engineers. Okay. So now what will happen that if suppose this user one, he is developing code, he is pushing the code, assume that there is a separate folder or the there's a separate folder or there's a separate repository has been created for this particular project. Suppose like they'll create mkdir slash vlc project, something like that, and they'll make it as a git enabled, so that they will run the git init bear command to make it as a git repository, right? So now what to do, this will be a separate project where people are developing. So what happened that, and for this, right, this vlc project, right, this URL or this directory structure will be placed to all, it will be shared to all the users, so that they will know where I need to push the code. So those things we will see later, how they will share all those things through a URL or through your the complete path of that repositories. It will be shared to all the users actually. Okay. So now what happened, like the user one, he will be writing the code for 1.1 version, but he will be pushing that code into the same repository folder, correct? Even the user 2 will also be pushing the same code. User 3 is also pushing. Fine, because these three people are working on the version 1.1, but that is fine. But whereas the other four users, right, even they'll be writing the code for the 2.1 version, and they'll be pushing the same code under the same project. So what happened is there is lot of like code is committed, and it lead to a lot of confusion, because these people are working for a 1.1 version, whereas these four people are working for a 2.1 version. So there will be a lot of code changes between these two versions, right? So in that case, what happened, right, committing into the same in one particular single location is not good actually, it's not correct. So hence what they will do, right, they will try to create a branches actually. How to create a branch, what will do, they will create a branch like this actually. They'll create a branch like this. They'll create a branch like this. So what they will do, they will create a branch. They will say something like a branch PLC 1.1, something like that. And similarly, they will create this branch like this, actually. Branch VLC 2.1, something like that. And now you will tell that, okay, all these three users, whatever the code push you want to do, you want to push into this branch. Okay. And here again, all these users who are all the other four users who are working for a VLC 2.1, they will be given instruction that whenever you want to push the code, please push the code under the branch VLC 1.1, so that there is a differentiate between all these users. Correct, guys? Do you agree with me? I hope you guys are understanding what I'm saying. Guys,
Yes, yes, that's fine.
yeah. So now what happens that actually, okay, fine. Now it has been a separate branches are being created, fine, so they are committing the code changes into that particular branches, fine. Now what you'll say that suppose the project manager says that, okay, we want to release this vlc 1.1 to the customers. Now we have to release this product to the customers. You know very well in the industries, right, what will happen that, what exactly it happens that actually that whenever they want to release the code, what they will do, this is the main branch, or this we call it as a master branch. This vlc project, right, sir, this is called as a master branch, sir. This is called as a master branch. So whatever the code base is there, no sir, whatever the code base is there, this code base, they will try to merge this code base to your master branch. First they will merge it actually. So I'll write it down. First they will merge the code. So we are using some terminologies, merge and all. We will see later what is this thing. But right now try to understand. Merging means they are actually integrating this code from this branch to the main master branch. Right? Once it is done, what they will do, you know that every company have their own they have their own build process. So you know most of the companies, they are following up the Jenkins, right? Basically they'll have a Jenkins configured over there. So and also what happened, right, this Jenkins will be integrated with your Git server, correct? With your Git server, correct, guys? Now what has happened, right? After the merge is done, the merge is done to the main master branch. You have a build server over here under the Git under the Jenkins. Okay, if it is a Java project, you will have something like a build tool like Maven we have, right? Maven or Gradle or anything. So you will be having a build environment. So what will do, it will try to pull the latest code And what the Jenkins will do, Jenkins will try to compile the code, or through with the help of a Maven, it will try to build the code. Once it builds the code, what happened, right? It is going to create a repository, or it's going to create a not repository, it's going to create a executable. That executable, what you will do, you will try to push that code executable into your Nexus repository somewhere. Suppose if you have an Nexus, okay, you know that you will be pushing that code into your Nexus repository, right? Nexus repository. After that, what you will do here, you need to push whatever the code is there to finally to your production server. So there has to be a deployment server, correct, guys? So you have a deployment server. You can either write a shell script or a Python shell scripting or anything for the build. But right now we are using an Ansible. Ansible is your nothing but your it's nothing but your deployment server, or it's not, but it's a configuration manager, but you can do a deployment, right? So what you do that your Jenkins is integrated with your Ansible also. Now you are actually calling Jenkins. What Jenkins will do, whatever that is the code which is there in Access, right? It will try to take that code, and you have a servers here, the production servers like this. Sorry, I don't have a space. I'm just writing here. You have production servers like this actually. So what happened? You are having a lot of servers inside, right? This is a production environment. So you are having a lot of servers like this, and these are all in the clustered environment, correct? So what Ansible will do? Ansible will take the code from the Nexus, and it will try to push the same code here into all these servers, right? Basically, some playbook have been written. That playbook will get executed. That playbook, what it will do? It will try to install, or it's going to push this VLC package into this production server. And you know very well that actually here somewhere our outside, our customer is sitting somewhere right here. This is the network actually. Here somewhere our customer is sitting over here, right? He want to access that VLC player. What he will do? He will try to connect to the internet, right? From the internet, what is happening that there is a in between that there will be having some kind of a load balancer gateway. So this is a load balancer. So from here load balancer, the request will go to here. The request will go to from the internet. The request will go to load balancer. From the load balancer, it knows that okay, this particular user requires the VLC 1.1. Okay, let me connect to this any one of the production server. From where it will try to take that software, and he'll try to download and install it. Correct, guys? So this is what some kind of an architecture, right? Where you will get a complete flow of the production environment. It is something like a pipeline where you can see it, right? So here what is happening that VLC 1.1 was merged into the master branch, and finally what happened? Some kind of a CI/CD pipelining was happened where finally the code was pushed to the production environment. Correct, guys? So similarly, after some point of time, your manager comes back again. He said that now we need to release the 2.1 version. The same thing will happen, sir. So what happened that this same thing, this code will be merged into a master branch. It will be merged. Once it is merged, everything happens, right? Once the merge completes, again what happened? The Jenkins is going to pull the latest code from this master branch. Once it does it, pulls it, it does the build deployment, it does the build activity with the help of a Maven. It does the build. Again, you can have some kind of a Sonar Cube also, because Sonar Cube, if you install, it does some quality gateway checks. It does actually. Once it does the quality gateway checks, once you see that there is no error, or there is no your code quality is code quality. The quality of the code is good actually, it meeting all the criteria, then the particular exe or the executable will be pushed to the Nexus. From the Nexus, whatever the Ansible server is going to push it, pull it, the code, and with the help of some kind of a playbook file, it will going to push into the all to the production server. This is how it happens, sir. Clear, guys? I know that, sorry, there was some space constraints there, but overall you understood, right? So that is what we call, we maintain a different branches. Correct. We just explained a very high level, sir. When we start working on a branches, how to create a branch, how to shift from one branch to other branch, how to toggle between one branch to other branch, as well as how to do a merge of the code from your sub branch to the main branch. What is a merge conflicts, and we will be seeing all those things later. Okay, guys. I hope you understood the whole, like the whole picture of how the Git overflow works. Correct. And we have gone through some terminology also. We have seen, understood all these terminologies. Correct. Okay. Now what is, okay, this is what it is. Now what we have to understand more now. Now this is nothing but the Git server, okay, fine, and this is nothing but the Git client. So Git client, or the user or the developer where the Git is installed, he will basically have his own local repositories, right? He will have his own local repositories. So he has some kind of a local repo. We call it as a local repository. But this is one stage which is there within the user. But apart from that, there are three more stages are there. But I will not be discussing the other three stages. Only the two stages I will discuss. And before this local repository, there is one more comes, which we call it as a index area, or we can call it as a staging area. Both are same. And one more which we comes is a working area, or we can call it as a working tree, or we can, some people call it as a working tree also. Both are same actually. So you have a working area or working tree, you have an index area, or you can call it the staging area, and we have a local repository. Okay, these are the three things. These are the three terminologies which we have to understand actually. So this, all these three stuffs, right, which will be there within that particular user. Like suppose like I have a Windows or I have a Linux, I have installed the Git, right? So I need to do the code changes. I need to commit the code changes within my local server itself, within my local server. So in that case, actually, you have to come across these three different stages actually: working area, or the working tree, staging area, or called index area, and finally local repository. Clear, guys? So this is nothing but your, actually these are nothing but, we call this as a Git stages actually. Git stages. Okay. So finally, whenever any software codes comes under the local repository, okay, whenever any software code, or software code, or the source code comes under the local repository, then we can say that the code is under versioning. So then only we say that the code is under versioning. Suppose your source code is not in the local repository, it is there in the staging area, or it is in the working tree. We cannot say that code is under versioning. No, whenever the code finally comes to the local repository, then that software code will be, we can say that it is under the source code versioning now. Clear, guys? Okay. Now what we are going to do with this actually, basically, with all these things, what we will do, we will try to have a setup where we'll have some three servers, guys. So what I will do, I will have some three servers. Okay, some three servers I'll have. Okay, what I will do, I'll have something like a Git server. It's a main server. Okay, and basically I'll be choosing either OS 7, or I will choose the Amazon Linux itself. Everything you can take anything, no problem. Okay, so you can install, you can have a CentOS 7, or else CentOS 8, or else Amazon Linux. Okay, this is one machine. I will have two more machine. So one is, the second one is called as a Git client 1, and other will have a Git client 2. Okay, we'll have these three servers, something like this. So we'll have one server here like this, and two more servers like this here, like this. So this we call it as a Git server. Okay, what I will do, sir, I will use the Amazon Linux itself in this class. Okay, I will not use CentOS or any other flavor. I'll use a Git. I'll use a Amazon Linux. This is Git client 1, and this is the Git client 2. Git client 2. Okay. And what you have to do, that because it's a Linux operating system, you have to install the Git software. To install the Git software, you have to run a command yum install git -y. Same command you have to even execute here also, because you have to install the git package, sir, everywhere. Ultimately, at the end, I'll be calling this as a git server, but you have to install the git package. You have to install. That is mandatory in every machine. Here also have to install it actually. You have to even note down some IP address also here. So I will, after once I like once I create a servers, then I will see what is the IP address. But right now I will just try to launch some three instance now, and then like I will make one as a Git server and other two as a Git client. Okay, guys. So what I will do, I'll just go to my Amazon Linux. So I'll go to the console.aws.amazon.com. So you know very well that you will get a login page of your Amazon account. So where you have to log in. So I'll be logging with my account. Okay. It's very simple, sir, the setup. So this we call as a, what is this? How to set up the Git server on premises. On premises. Okay. So, okay. So we launch the instance. So as I said, for this example, I need three machines. So let me launch the three instance. So I'll say launch instance. I'll choose this Amazon Linux 2 itself. Okay. And I can go with the t2.micro because this is sufficient for my experiment. Okay, I'll go to the next. Instead of having one instance, I will make it as a three instance. Okay. I'll go to the next. And again, next. Don't give any tag. You can give later on tag. So here I'm just selecting my default security groups, launch, and finally say launch. Once you say launch it, you have to provide the key pair. So I'm having already KATS. So I'll just try to acknowledge. So now you have launched some three instance actually, right? Three servers, which is Amazon Linux. Okay, it takes some time. Okay, so all these three servers are up and running. So I'll just give a name. So I'll give the name as a Git-server. So this is a centralized server or the main server, I will say. And this I will call it as a Git client. Git client 1. And this I'll call it as a Git client 2. Here guys. Okay. So I have given the name for this, all these three servers. So let me note it down the IP addresses for these machines. So I'll just click on it. I'll go to the networking. I will copy the private. I don't want the public. I'll just copy the private IP address. I'll copy it. So this I'll act as a Git server, right? So I'll copy it here. In this diagram, right? I will maintain it actually. What is the IP address for this? The IP address for it is not what 172.172.31.88.239. Similarly, I will go over here. So let me do one thing, sir. Let me even copy in my notepad also. Git server. Okay. Then I will have a Git client 1. So what is the IP address for the Git client 1? So you have only the private IP address, that is sufficient, because all these three servers under the same region, right? So you can communicate each other with the help of a private IP address also, right? So this is for the Git client 1. Similarly here in this diagram, You will say git client 1, the IP address is this. Okay. Then finally you have a git client 2. Copy this, paste over here first, git client 2, client 2, and here the same thing, you can even paste it here also. Okay guys, so these are the IP addresses we have. Now what I have to do is here basically that here in the Git server, what I will do, guys, today I'm not going anything in detail with the commands, Git commands. Okay, I'm just explaining you few of the things how you have to do a setup when you have given a task of setuping the Git server in your in your office or at your office premises, right? Okay, so how to do setup, that's what we are learning. Okay, it's a very simple thing. So you have to purchase the server, or you can even take up the server from the cloud, or you can go to the market, purchase new servers, install in your data centers, you can do that. Or else nowadays people are going to the cloud, you can choose any of the cloud, right? AWS or Azure or Google Cloud. Just try to launch some instance, and then like you can work around with this, right? So now here after this, what you will do, right? I want to create a directory over here, right, in my main Git server. So I'll do one thing, I'll say mkdir, something like slash project, I'll say. Okay, I'll create a project directory, and you have to do a cd to the project directory, and you know very well that I need to run a command git init -f bare. So this command you have to run under the server side. Similarly, here under the client also, what you will do, you will create one directory, same thing like slash day1 directory, cd to the slash day1 directory, and then you will first run git init command. Once after you run the git command, suppose you create a file, something like vi file1, you will create a file, and you will try to write all the codes of the file, all codes of the file, and finally once you do it right, you need to run some commands to make sure that all your codes are committed within your local repository. It means that within your system itself, or within your locally within the system itself, it has to first get committed. Once it get committed, later what happened, right? The code, the same code, you can push from your Git client 1 machine to the main server like this. Clear, guys? So this is what the activity will be doing now. Correct. So we will come across with so many other commands and all. You will watch it today, that like what are the different commands which you are using. In next class or in upcoming sessions, we will be completely going into a lot of different commands on Git actually. Okay. So that's how it is. And this is what the client 1 does. Client 2 doesn't do anything. What he will do, he will go for a vacation. He'll go for 1 week vacation. He will come back. Now he will see that already the client 1 has Git client 1 has did so many changes in the source code. Finally, he want to pull all those changes, whatever is there he has did now, whatever he has committed into your main Git server, it has to pull the code. So what this person will do, this Git client will do, he will try to do a pull operation like this. That's all he will do. Once he pulled the operation, whatever the latest changes are there, that whole the complete source code he will get under his local repository. And now on top of that, he will start working on it. And later, if he want to commit any code, he will commit it like that. So these are some basic operations. So this will tell you how to set up your Git server on a local premises, on premises like this. Clear, guys? So now, so we are already having a 3 servers which are up and running. So I will try to log in each and every machine. So first, let me log into the Git server. I'll copy this public IP address, go to the putty. You know very well, we have been doing this from long time. So I'll say EC2 user-user and copy the public IP address. So I'll do one thing, I will just change the appearance here, and background color setting also change. And here you have to go to the auth, and you have to select that PEM key, right? Or the PPK key, sorry, not PEM, PPK key. And also open. See, you have launched the instance. So this is nothing but your Git server. So what I will do a sudo to the root. If you need it, you can even do a host name ctl set hyphen host name space, you can say git hyphen server. correct? And if you execute the bash command, see, you have got the username with host name with the name Git Server. You can do like that also. Okay. Similarly, what you have to do there, you have to log into the Git client one, go to the networking again, copy this public IP address, open the launch the putty session, ec2-user @ specify that public IP address, go to the appearance, change the font size, coloring, and finally you need to go to the auth, change it, sorry, select the auth, select this ppk file and then say open. So you have logged into the Git client one now. So what I will do, I'll do a switch to the root user, fine. And then what I will do, if you need it, you can even change the host name, ctl set -host name. This you have seen many times. And I'll say Git client one. And you can even just simply get into the bash. See, you got it. Here guys. Now the same stuff I'll be doing in the client two also. Git client two. Copy this public web address, launch the instance, ec2-user give the public IP address, go to the appearance, change it like this, give the background color, you can give any color, I'll be using the system color. Then you go to the auth, select your ppk file over here and then say open. So switch to the super user. So sudo su means switch user. To which user? Root user I'm switching. Okay. Then host name ctl set -host name and then say git server git client -2 and then say bash. Clear guys? Till here clear? Now you have to install the Git package here because it's a Linux flavor and it follows up the yum install package. You have to run a command yum install git -y. So run this command. So I'm running this command. So you could see that it is installed in the Git package. The same command I need to run in the other server also. Yum install git -y. So this is in a client one, and similarly in the client Git client two also I will run the same command yum install git -y. Guys, are you able to understand till here? Any doubts you have? It's pretty simple, right? We are just trying to install some packages. That's all. Correct? So here the installation completed. Here also completed. Here also completed. You can cross verify if Git is there or not. Git -FN version. So this has to show some version. Yes, Git is installed. Same thing. Git -FN version and Git -FN version. No doubt, everywhere, all these three machines, the Git installed. There's no issue with the Git because it's very simple software. Okay, that's the reason the installation is very simple. So it has installed in all these three machines. Now, all these three machines having a Git package, fine. But you will make any one server as a Git server, right? So here you have already chosen this as a Git server. Correct, guys? Now, before we start up working on certain things or try to understand certain things, what I will do in all these three machines, because these three machines, they have to communicate each other. Correct? There should be some kind of a passwordless communication should happen between these three machines, right? Because if the Git client, he's submitting the code into the server, okay, while he's submitting, it shouldn't ask for the password, correct? It shouldn't ask the password for the Git server because Git server is maintained by some Git administrator, right? Why he's going to share the Git password to you all the different clients? Why he doesn't? He shouldn't share, right? Because it's like it's a security breach. He shouldn't do it actually. So, but whereas when you are doing a committing the codes or when you're pushing the code from your server to this server, obviously it will try to ask you the password, provide the password while doing a push. So what you need to do under that case? Similarly, the client too, he is trying to pull the code. While pulling the code, it will ask you the password of your Git server, the main Git server. But the Git server password, who will share the Git password to you? Nobody shares, because Git admin will never share the password of the Git. So what the Git server will say, Git server or the Git administrator who is maintaining the Git server, right? Whatever it says, okay, Git client one, you want to push the code, okay, fine. While pushing the code, it will ask you for the password. I cannot share the password to you, but what I can do that, whatever your public key is there, right? ID underscore RSA public key is there. That public key you share with me. I will add that public key into my authorized key, so that while pushing the code, it doesn't ask for any password. So what this person will do, the Git client one, you know very well that he will run a command ssh-keygen. Once you execute this command, there are two important files will get created: id underscore dsa, id underscore rsa, and id underscore rsa.pub. So what he need to do, this client one, he need to copy the content of this public file, and he need to give it to the person who is maintaining the Git server. Clear, guys? Similarly, even the client one also, what he will do the same command. He will run this command ssh-keygen. It will create two files like this. Share this public key. Share this public key. So who's going to share? The Git client 2, who is the user, right? He will take the content and he will share that to the Git administrator, or the person who is maintaining the Git server. So he will give to the Git administrator. So what the Git administrator will do, he will take this file content under this Git server. What happened was, sir, under the SSH directory, there is one file by name authorized underscore keys. So he'll just simply copy paste the public key of Git client one, and he will copy the public key, means whatever you guys have shared, right, that of the Git client 2. He will just copy paste that content, sir, this file content, into this authorized key file. Once he copies it, then it means that you can do a communication without any password. Is it clear, sir? Guys, are you clear with this, whatever I said till now? It's a very important thing which I'm telling you. Okay, if you have any doubts, please ask me now itself. Don't go without understanding anything. You have to understand each and everything, whatever I'm teaching you or explaining you. Clear, guys? Okay, so I'll assume that you guys don't have any doubts. Okay, it's clear now. Because all these three machines, sir, these three machines we have took from your AWS, right? AWS, Amazon cloud. By default, it doesn't allow for the root login, or by default, it doesn't do any kind of a password authentication. So to do that, you have to enable the password authentication. To do that, you have to do some changes. Okay. Suppose that these three machines you have set in under your VMware workstation. Then you need not to do all the steps what I'm doing now, because we are in the cloud, because it's an AWS cloud, and we have launched this three instance. You have to enable the password. No password. Password. You need to enable the password authentication. Actually, to do that, how to do that? So the first step is vi etc sssd underscore conf. This is the file. So you can just note it down. Like, I think this already I have explained you in the other previous class also. So this is the file. Okay. So you have to open this file. So come down over here. Here you can say permit root login. That you can just enable. Okay. Once you enable it, come down over here again. Come down. You will see that something was a password authentication. Password authentication, from no, you have to say as a yes, actually. Yes, that's all. And save the file. Save the file. After you save the file, you have to say systemctl restart SSD. You have to run this command, as well as a systemctl status Just check the status whether it is up and running. It should be active and running. If it is exited out or if it is not running, then there's a problem with this SSD service. It should always be active and running. Okay. So these are the things you have to do. And later, one more change one more thing what I have to do, you have to set a root password also. So what I will do, I'll say passwd, and I'll say enter. You are setting a root passwords. Okay. So I'll give the password as Red Hat, enter. I'll give the password as Red Hat. Okay, you set the root password as Red Hat. Okay, fine, sir. The same stuff you need to do in all the other two machines also. Like I'll go over here. I'll say etc sssd underscore conf. Open this file. Come down over here. You can remove this line. You can remove this hash. You are uncommenting. You say that you are allowing the root user to direct login in, and then like you have to come over here. Here you have password authentication. No, just change it to yes. After that, save this file. Then systemctl restart SSD. To check the status, what you have to do that? You have to say systemctl status SSD. It should be active running, right? And then you are setting the root password. For give the password as Red Hat only. For here also, I'll give the password as Red Hat. Okay. It's a vi etc ssh sssd underscore conf file. Root login password. Remove the hash. And then password authentication, you have to say from no to yes. Save this file. Then run the command systemctl restart SSD. Check the status systemctl status SSD. Guys, okay, and then you can say you can set up the root user password pswd command. Enter Red Hat. Enter Red Hat. Enter. So now all this setting is done now, guys. Clear? All these three settings are done. But you need to maintain IP addresses because I will be doing some kind of a SCP command and all to make sure that I'll be doing. Yeah. One more thing actually, how the communication happens from the Git client to the Git server. Basically, you can either have a communication by using SSH. It basically happens, or else you can even use HTTP communication also. Any way you can do a communication. Basically, we are always using most of the time you'll be using SSH. Also, you can even do a communication with the HTTP also. Okay. So whenever the client one want to communicate with server, he want to push the code, he can use a HTTP protocol or SSH protocol. Anything he can use. Okay, guys. So this they will ask in an interview. What is the protocol being used to communicate between the Git client to the Git server? It is either HTTP or SSH. You have to say. Okay, both can be used. Okay. So now, so what I'm going to do here is that actually that in this case, in this example, so I will go to the Git server. So this is my Git server, sir. What I will do, I will do a mkdir project. I'll create a project directly like this, and I'll do a cd to the project directory. Here, guys. So now nothing is there over here. So now what happened? This is just an empty directory or empty folder. So it is not under versioning. Whenever you want to make it as a Git server, you have to run one command, so Git Init --- bear. So this command you have to run it. Once you run this command, you could see that it is initialized the empty Git directory in the project directory. And if you say ls, you could see that these are all the configuration files related to your Git server. So it means that now this will act like a Git server, sir. Similarly, what you are doing that you have to go to your Git client one. And here what you have to do that you have to first create a directory. Let me create a mkdir/day1 directory. Okay. As we discussed in the diagram, right? I will go through the same thing, whatever I have discussed in the diagram. Okay. So I'll say mkdir day1 directory, fine. Then what I will do, I will try to log into the day1 directory, and then I will run a command as a git init. Once I run a Git init, it comes under your it is comes under or it is initialized as a Git repository. But you could see that under the day1 directory, it has created one dot Git directory. If you say ls, nothing will be seen. But if you say ls-a, you could see that there is a hidden directory there. So if you get inside the dot Git directory, ls, see here also you could see some of the files actually. So these are all related to the states that your folder slash day1 is under the versioning now, Git versioning now. Okay. So if you are removing this directory now, dot git, no, you are losing the complete versioning. So never ever touch this dot git directory, sir. Guys. In your real time also, whenever you say dot git directory, right, don't do any changes to this file, or don't move this file, or don't remove this file. Don't do all those things. Okay. So it maintains the versioning of the complete slash day1 repository. Okay. So now this slash day1, it acts as a local repository, and this slash project will act as a centralized repository. Clear, guys? Now, what you have to do is that actually, guys, once again, I'm getting one call, small call. Okay, guys, sorry. So here, so that's how it is. Now you have a slash day1 directory. Similarly, I can even in the client 2, I can create a mkdir slash dev2 slash dev2 cd to the slash dev2 and run the git command, git init. So please, you try to understand that here in the client side, I'm running the git init, whereas in the server side, you are running a git init -bear. This comparison you have to understand. Okay, whenever you are making it as a centralized repository or main Git server, you have to always run a git init -bear. You have to run, right? Somebody might get it, or why I'm not using this over here. So you shouldn't use it because you are this act like a git client. So the git client always you should run, just run git init. Clear, guys? Similarly, I have executed the git init here in dev2 under the client git client 2 also. So it is also now under the git versioning. Clear? Now, what I will do now, guys, now what I will do that I will try to create one file under the slash day1. I'm already under the slash day1. You could see that I'm under slash day1. What I will do, I will try to write some file, something like file1. Okay. Or let me do one thing, guys. Let me create one file1. I'll say touch file1. I'll say touch file1. It means that you have created a file1. Now let us see whether the Git will give any kind of a status for this file1. So to get the status, I will run a command git status. See what it says that git status. It says that you are under the main master branch file. No commit is yet. So this file1, it is an untracked file. Untracked file, it means that still this file1 has not come under some kind of a revision or versioning. It is just to be called as an untracked file. Now he also says that to make it under track or to make it under versioning, or you want to commit it, you have to just say git add and specify this file name. Right? So here what he says that it is still under the untracked. To make it as a track, you call it as a git add and specify the file name. You could see even the color also. See, it is showing in a red color, sir. Correct. So git will tell you the history actually. So what the git status command will do, it will tell you the history of the git versioning. Okay. So now here what happened, right? In when it comes to diagram, here in the working area, you have created that file by empty file, touch file1. So what is our working area means, what are all the files which you are seeing here? Suppose if I say ls here, see, I'm seeing so many files. Suppose here it is only one file. Oh, it means that this file is under working area. It means that it is under your current path. Now what has happened that from your current path, he says that this file is under untracked file. You have to make it track. It means that basically you have to move this file from the working area to the index area or to the staging area. You have to move it. To move it, what is the command you have to do? guys, git add and specify the file name. What I'll do is I'll say git add and specify the file name. The file name is file1. Now it has been moved from your working area to the staging area. Okay. Now if I say git status, now you could see it has turned under the green color. Now earlier it was in a red color. That means it is under the untracked. Now it is under tracked. See, now it came under the tracked file. It means that what it says now is that it says that change to be committed. It means that further if you want to do any kind of a commit, you can do to the commit actually. It means that you can do a commit to this file. Now, suppose somebody might ask you like, what is this indexing area? What is this local repository? We will get into detailedly later. But what I'm saying that there are three stages within your local repository. Within your local repository, it means that this is my day one or Git client one. Under the Git client one, when I've installed the Git, I have to perform or I have to move my file, source file, under the local repository so that it will come under the versioning. The source code comes under the versioning or it comes under the versioning. Unless and until you don't make it under versioning, what is happening that your files will not be tracked or your file will not be having any kind of versioning or revision, right? So that's the reason what happened, right? You have to move your file from your working area, that is from your present directory, to the indexing area, and finally from the index area you have to move to the local repository. So from the working area to the index area, you know very well that you have executed something like a git add. You executed git add, correct guys? Git add, fine. Now from here, because now you know that, see, your file is empty guys, nothing is there. If you do a kite one, nothing is there. Okay, fine, you will say that okay, even though my file is an empty, still I want to move my empty file into my local repository. I want to move here. So to move it, what you have to do that you have to do a commit actually. So what is the command you have to do? You have to say git commit -m and specify the message actually. What is the message you want to pass? And finally the file name. This is the syntax. But the condition is that actually before you do a git commit and specify the -m is message, some message you want to pass it, and finally specify the file name. Before you do a git commit, sir, you need to do some kind of a global setting. What are the global setting is that actually you need to set up the git username and the git email id. To do that, actually what to do, say you have to say that git config -n global user dot name is something like Rajesh, let's say, and I'll say git. You have to execute this command before you are executing the git commit. User dot email Rajesh SRE something @gmail.com. You need to run this command. Now assume that I'm not running these two commands, sir. Just let me see if I commit whether it works or not. Okay, I will do one thing. I'll say now under my file is under the staging area. You know that now your file is under the staging area or index area. Okay. Now from here I want to move to a local repository. So to move to the local repository, what you have to run the command, guys? You have to run a command commit, right? Commit. But before you do a commit, as I said, right, you need to execute these two commands first, and then you do it actually. But okay, fine, I'm not executing these two commands. Let me see if the commit goes fine or not. So I'll say git. Let me clear the screen. Git commit -m. Specify some message. What I will do, I'll say first. I'll say this is my first commit. I'll say first commit, and specify the file name like file1. See what it says? Please tell me who you are. See, execute this command. See, git config -n global user email, git config -n global. See, it is telling you that you first give this entries, then only you can do a commit. So for that reason, I'm saying that I'll say git commit config -n global user dot name. Specify your name. So now the next command git config -n global user dot email id. So what is the email id? Mail Rajesh SRE. So now you have did the global configuration setting. You have did it now. Okay. Once you have set it, Now again, you can run a git commit -m and say first commit. That's a message and the specify the file name. Now you could see that it has been committed. Right. Clear? It has been committed. Now if you do a git status, git status will tell you that what is the status of your current file. Is there any, what are the changes or what are set? It says that nothing to commit. It means that nothing is, everything is clean. It means that already you have committed. There are no more changes to the file. Already this file is under committed. Now to check the history of it, you have to run a command git log. See, git log will tell you that already there's a file by name committed, file one. It's the first commit, sir. And who is the author? That is Rajesh. What is his email ID? Okay. Whenever you are committing, sir, guys, whenever you are committing from your index area to the staging area to the local area, what happened that there is one commit ID will be provided for each and every change. See, this is the commit ID. What is this commit ID and all, we will dig into it later in a very in detail manner. But right now understand that for each and every commit, a commit ID will be provided. It will be given, and that is maintained by your Git itself. So that's the reason if you do execute a command git log, it will show the history. And here you could see the head point to the master. This and all we will discuss later. But as of now, you have to understand that for each and every commit, there will be a commit ID will be provided. Of course, some details like author name and who is what is the email and what's the time and what is the message, commit message. See, when I execute git commit -m, I provided the commit message. So that is a commit message it is showing you. So now what happened, right? Now your code, it is there in your local repository. So it is successfully, it is placed in local repository. Means that this file one is under now, it is under versioning now. Correct, guys? The file one is under, this is the source code, right? This is under versioning now. So now what you have to do from your, so this is what you have did here till here, correct, guys? Now from here, you need to push this code from your Git client to the Git server. You have to push this code. Clear? To push this code, sir, you have to specify what is the origin or what is the path where your project is, I mean, where your repository is there. You know that under the Git server, if you execute a pwd, now you could see that under the slash project, you are running the project. Means that I need to commit the code under this path and to the Git hyphen server, right? So now what you will do that actually, first in your Git client, that is a Git client one, what you do, you have to run this command. Just carefully watch what I'm doing. Git remote. First, I need to specify Git remote add origin root @ what is the IP address of your Git server? The IP address of the Git server is this, right? So copy this root @ given it, and you have to say colon. So where you have to commit? You have to commit under the slash project. So you are telling to a client that okay, this is the path. So you are adding it remotely, this complete path of the server where you are want to commit it, right? So first in your Git client one, you have to execute this command, git remote add origin root, because you are working as a root user. Everywhere you're working as a root user, you have to specify the root specify the IP address of your Git server slash project. So can we execute this command? Yes. So now it has been added. It means that whenever you are doing a git push, it will try to push the code under the slash project. So now what I will do here, I'll come back over here. I will say git push origin and say master. Now you are pushing the code. So what you are doing now? Now you are pushing the code from your local repository to your Git server under the main under the location slash project. You are pushing it. But as I said, right, while pushing it, it will ask for the Git password, Git server password. But Git server password, Git administrator, why is going to share with the Git client? If we start sharing his the password to the Git, all the Git clients, right? There's a security breach is there. That is not possible. So hence, what is happening that you have to give your public key to him. Actually, he will later copy the content. He will paste under the authorized key. That's what we discussed, right? So now, okay, fine. What I will do, I'll try to see. I'll try to push it. I'll do a git push origin. Let us see what will happen. See, I'll say yes. See, it is asking for the password of the Git server. Guys, do you know the password? In the real time, do you know the password of the Git server? No, right? We will not be able to know, right? Okay, I will not be able to do that. So now what I will do, what this person Git client will do, right? He will try to run a command ssh -keygen. He'll run the command. Don't do anything. Just enter, enter, enter. It will create two keys. So it will create a .ssh directory. You know that .ssh directory will get created. You do a cd to .ssh directory. Get inside it. You have a id underscore rsa.pub. Open the id underscore rsa.pub. Open this public key. Copy this public key and give it to the Git administrator. Give to this Git administrator. He is a Git administrator. You just pass this content of the id underscore rsa.pub to him. So what he will do, he will copy this content. He will go to his server. Under his server, there is something like a .sh directory will be there. Under that, can you see there's authorized key there? If it is not there, you manually create it. Now you will open this file authorized key, come over here and just paste the public key of the client one and then save it. That's all you have to do. Now, after doing it, go back to your project one, project directory. Go back to the project directory and say ls. Okay. Now, again, what this guy will do, he will say, okay, now he has given the public key. He'll go back to his local repository, that is /day1. Here, what he will do, he will say git push origin master. Now you could see that it will push the code. It will not ask any password. See, now the new branch master branch, see, he has pushed the code actually into your main server. Now here what he will do, the Git administrator, what he will do, he will come over here. He will just run a command as a Git log. See, oh, he could see that, okay, somebody by name Rajesh with his email ID, he has pushed the code into my Git server under this project directory. Clear, guys? So now let us do one more experiment. Let us do one more thing. I'll go here in the client one. Now what is happening that I have a file. Let me open this file now. Now it's an empty file. So what I will do, I will try to add something. Welcome to Git session. So he's adding just first line of the code. Save this file. See, now what is happening that he has did some changes to the file. Right, the user earlier it was an empty, he committed the empty file itself, fine. But now what the same client one is doing, he is trying to edit the file. He has added some line. Now let us see the status of the git status. What is it? See, he says that it has been modified, guys. Changes not stage to for the commit, it has been now modified actually. Now he has to do a commit again. So I'll say git commit -m message. What is it? I'll say second commit. Okay, and specify the file name, file one. See, now it has committed. That means that what are the changes? Now again it has been pushed to your local repository. From the local repository, again what has to do? He has to push this code to your Git server, right? So what he will do? He will say git push push origin. Sorry, git push origin master. He has pushed it. Now again what happened, right? He has pushed the changes to your Git server. What the Git server will do, he will come over here again, he will run execute command git log. See, now the second commit has come. It means that first commit was an empty file. The second commit, what is there? It is having only one line of code, which is there. Correct? This is one line of code. It's there. See, this is one line of code, that is welcome to Git session. This also has been pushed to all these days. What is happening all these days, right? The client one or two was in a holiday. So now what happened, right? He'll come back from the vacation. And so what he has to do, he has to do a git pull. He has to do, right? First, what he has to do, he has to do a clone of this project under him, and then he has to do a git pull actually. Again, what happened when he's doing a code pull or anything, he'll ask for the password. So what he has to do, he has to create an SSH key, run a SSH keygen, and give the content of this ID underscore RSA to the Git administrator. He will place it. Same thing. So whatever we did for Git client one, Same thing. Git client to what he'll do, he has created a dev2 directory, but in the dev2 directory, nothing is there. So first what he will do, he will run a command ssh-keygen, sorry, ssh-keygen, he will run the command like this, okay? So we go to the .sh directory. Under that, there's a id underscore rsa.pub is there, public key. So this, the complete content of this file, he will go to the Git administrator. What he will do, the Git administrator, he will copy that and he will go to the .ssh directory. Under that, he will open this authorize key and he will come and he will just append at the end of the file. That's all, sir. And he will save this file. So now what happened that the Git client 2 can also communicate with the Git server, right? So now what Git client will do, Git client 2 will do, he'll go to his directory /dev2. It is already under versioning because we already executed the Git Init command, right, earlier. So now what he will do, he has to clone the whole project, sir. So to clone it, what he will say, he will run a command git clone. So root user, what is the IP address of your IP address of your Git server? So this IP address of the Git server, right? He will copy it actually. Copy it here, paste over here. And what project is trying to do a clone? Project actually, correct? You'll just say yes for the first time. So now you could see that under his directory, he has pulled the complete source code of project. See, he'll go to the project directory. Okay, under that there's some file is there. He'll do a cat of file one. Now you could see that. See, this is the changes. Correct, guys? So client 2, he is able to pull. So first to do that, he has to first run a git clone. He has to run a so git client 2. He's not committing any code change. First, he's trying to pull the code, pull whatever the code which is there under the Git server. And then once he's doing it right, basically what is happening is that actually the complete, the whole project will be copied under his home, under his, under his local repository or under his local repository. That's what, right? So now what he will do that now, what again the Git client will do, one will do, he'll do one thing. Now again he will add it some more content. Git under the Git file one. Okay, welcome. Welcome to Git something. Anything. This could be any line of Git session 2, right? Just save this file. Now again he will say Git status. So you know that when it's Git status, it says that it is under modified now. So you'll see do a Git commit -m and specify it's a third commit. So he will give the message as a third commit. And he will give the specify the file name, file 1. So he's committed now. So when you do a right, he has committed. Now he has to push the code. So what he will say, he will say git push origin master. Like that, he'll push the code. So once he push the code, he'll come back over here in the Git server again. The main Git server. In the main Git server, you know very well that. Now if you execute a command git log, see there are 3 commits are there. First commit, second commit, and third commit. Now the third commit is done by the Git client 1, but the Git client 2 doesn't know about the commit has been done by the Git client 1. So he want to see the latest code check he want to do. So what he will do, he will do a git simple. He will not again do a clone because already has cloned it. He has to do a git pull origin master. So he is doing a pull activity now. See, now you could see that. You could see one of the other terminology here, fast forward. This is one of the interview question being asked. So I will explain about later what is a fast forward. But now what has happened? He has successfully pulled the code. So what the Git client 2 will do, he'll do a ls and he will do a cat file 1. Now he could see that the second change also now he could see here. Clear, guys? So now you understand that we came across with some commands, right? So what we came across git push, git pull, git clone, git origin, and like git remote add, those things and all, right? So these are the commands, right, guys? So I hope that guys you have understood the whole flow. So whenever a person is working locally in a file, he has to cross across these 2 stages. Some people will ask a question, sir, can I pass from this index? I don't want to get to index stages. Can I directly push the code from the working area to the local repository? They will ask the question. You have to say no. It is not possible. You have to get into the indexing area or the staging area. So from the working area or the working tree to your indexing area or the staging, you have to add it. From here to local repository, you have to do a commit. And you know very well that before you do any kind of a commit, when you do a git commit, right, you need to run that global configuration setting, right? This is what we discussed. Git config hyphen -f, you have to provide the username as well as you have to provide the email ID. This minimum details has to be given. And to commit it, you have to do a git commit hyphen m, specify some message over it, and finally the file name. Okay, guys. So this is what no like no a simple way of explaining you about. We just started with some few Git commands, not completely, but in the upcoming sessions we will be seeing more and more Git commands, right? And you could see that we are explaining about what is the commit ID, commit. So some people having some doubts of what is this, why we are setting this global configuration settings and all, right? So those doubts and all will be automatically will be resolved in the upcoming sessions. Don't worry about that. Okay, why Git is maintaining the Git commit ID and all, right? So those are all very important things we have to learn. Okay, that's the place where the interviewer will catch you. Actually, he will ask you more on that. What is the commit ID? Can I look into the commit ID? So can I see what are the changes in there, which is there in the commit ID? Is there any command? Like that, they will ask. We will go through all those things in upcoming sessions. Okay, guys. So that's what for today's session. So I hope that you guys have understood, no, the architecture or the Git overflow as well as the few commands. Right? We have discussed all these things. Clear, guys? So now let me know if you have any doubts, or else we'll wind up a session. So, guys, is it interesting? You found interesting in today's session? How was it? Like, is it a good thing for you to learn certain new things, or you already know means it is well and good. But if some of you have not known certain things, right? It was a no, it was a introductory session for you to understand few of the commands. Correct?
Yes, sir. It is very informative.
Okay, fine, fine, guys. So then we'll try to stop the session today. Okay, and